5.1. Your objective is going to find the inverse of a given function, give the domain and the range of f and of f inverse, and graph both f and f inverse. Most of the graphing will be done on the calculator. Okay, inverse relations. If the relation is defined by ordered pairs, interchange interchange the variables. If a relation is defined by an equation, again, just interchange the variables. So this is not really interchanging the variables, you're interchanging the values. There's no variables here. So find the inverse of the relation. This would be x, y. And this would be x, y, and in the inverse, you would switch places with your x and your y. So it would be 1, 0, 6, 5, and negative 4, 2. This would be the same as if you had a graph, whether you had a function or not, and they asked you to graph the inverse. You would just switch the x and y values and graph those. So on this one, find an equation for the inverse relation. On this one, just change your x and y's. So it would become 2y squared plus 5x squared equals 4. Again, because your domain and range is changing places. This one here would become x equals 3y squared minus 5y plus 9. Now here's the thing to notice, the square did not go with the x. You are only interchanging the x and y, not any powers, coefficients, or anything like that. Okay, so inverse function, if a function is 1-to-1, then the inverse is also a function. 1-to-1 functions, each x value corresponds to exactly one y value, and each y value corresponds to exactly one x value. 1-to-1 functions is a function is 1-to-1 if it can pass the horizontal line test. So there's two ways you can check. You can make sure that each x value has only one y value, but that defines a function alone, but each y value corresponding to exactly one x value gives you that 1-to-1. So if I did a horizontal line test on these, I could easily draw a line through anywhere on this graph, and you can see it's only going to cross that graph once. Whereas this one, if I can, anywhere I do it, I'm crossing it twice. So this one is not 1-to-1, where this one is 1-to-1. Now we can restrict the domain here at the vertex. We can restrict the domain and take one side or the other, and then it would be 1-to-1. But you'd have to restrict the domain for those. Okay, so this one here says graph the function, determine whether the function is 1-to-1 using a horizontal line test. Well, this one here, we're going to just sketch them. This is a line. Y-intercept is 3 with a slope of 4, so the graph's going to do something like this. And we can say that we can put a horizontal line anywhere along here, and it'll cross through that once. So the answer on this one is yes. Absolute value, so the x-coordinates, xy coordinates, -2, this guy went down 2, so he's down here. And he's V-shaped. And we can use the x-axis as a horizontal line, and the answer is no. This one here, y equals negative 0.8. So the line's down here somewhere. It is a horizontal line, which gives it an answer of no, because the y values are not changing. So each y, yeah, I got one y value going to every x value. This one here, if we graph this one here, we have an asymptote at x equals -3. So I'll just put something down here like this. And if x is 0, then it's going to be 2/3. So we're up here somewhere. So this graph is doing this bit here, and then over here it's doing this bit. And the answer on this one will be yes. It's going to look like when you get down here, if you graph it on the calculator, It'll look like it's almost a straight line, but it is not. It's just very, very slowly getting very, very close to the x-axis. Okay, this one here is a parabola that was raised at 3. So it's doing this bit, probably a little skinnier, but you can see you can easily put a horizontal line through there, and the answer would be no. And then negative x cubed raised up 2. So the vertex that would have been here is here, flipped over the x-axis, so our graph is going this direction. And it does this bit. And again, I can use the x-axis as my horizontal line, and the answer here is yes. Now, if you're looking at this going, how did you know what these graphs look like? In all honesty, you should know what an x squared graph looks like, what an x cubed graph looks like, what an absolute value graph looks like, what a horizontal line looks like, and what just any line looks like. This one was in the last section, or the last chapter, so you should have known that one as well. Number one thing when it comes to graphing is that you can recognize a graph. You know what happened to it. You know that, like this one here, you know the parent graph is x squared, and it was moved up 3, and then it was vertically shrunk. Or, yeah, vertically shrunk. Okay, so now with those, we can move into, if we have the equation. And a function is 1-to-1, a formula for its inverse can be generated by replacing f of x with y, interchange your x and y, solve for y, and then replace y with f inverse. You can't leave it as y because it's not y. We just solved for y. These could be done at the same time if you want. You don't have to do one and then the next. I will do all 4 steps. This one has all of your math. All of the math is involved here. So step 1 and 2 and 4 should not be the difficult steps. Step 3 should. Okay, so this one here, I'm going to go through all 4 steps. Step 1, change f of x to y. So y equals 1/4 x plus 7. Step 2, interchange your x and y. So x equals y. I'm sorry, 1/4 y plus 7. Step 3 is where all your math is. They want you to solve for y. So if I subtract 7, I get x minus 7 equals 1/4 y. And then multiply both sides by 4. I get 4x minus 28 equals y. Once you have it set to y, then step 4 is replacing y with f inverse. And we are done. Okay, let's try another one. Or maybe another 2. Okay, so this one here, step 1, y equals the cube root of x minus 5. Replace your x and y. So x equals the cube root of y minus 5. Add 5 on both sides. We get x plus 5 equals the cube root of y. And when you want to get rid of a cube root, it's simple. You just cube it. So we get x plus 5 cubed equals y. That brings us down to step 4. F inverse of x equals x plus 5 cubed. Now here's something I'm going to go ahead and point out before I do the next one. Notice here I had a cube root, but in my inverse I have a cube. I have minus 5, but in my inverse I have plus 5. We can do this on the last one. I was dividing by 4, now I'm multiplying by 4. Plus 7, minus 7. And you had the minus 7 here before I multiplied by 4. All of those inverse operations are going to happen as well. Okay, so this one here, f of x equals x to the negative 1 power. So this is y equals 1 over x. For those of you not remembering your exponent rules, a negative exponent just tells you it's not where it belongs. So you move it from the numerator and put it in the denominator. Those of you moving into calculus, we will do this a lot. Okay, step 2, switch your x and y. Okay, I'm going to multiply both sides by y. Some of you guys will look at this as just cross multiplying, which would probably be a little easier to do. Xy equals 1. Divide both sides by x. And you have y equals 1 over x. So last step, f inverse. Oh, yes, I just saw the 8. Don't ask me, I don't know. I didn't even say 8, I said x. F inverse of x equals 1 over x. So there's step 1, step 2, goes right into step 3, and so forth. Yes, this will happen on occasion that your inverse will be the same as your original function, which is okay. It's okay that it happens. Okay. So on this one, let's try this again. Step 1, y equals 2x plus 3 over x minus 2. Switch out your x and y. So x equals 2y plus 3 over y minus 2. And we start doing our math. Okay, so I'm going to multiply both sides by y minus 2. So I get x times y minus 2 equals 2y plus 3. So xy minus 2x equals 2y plus 3. Now remember, we're trying to solve for y, so I'm going to move all my y's to this side and all my x's that way. So I have xy minus 2y, move this y over, equals, move this x this way, 2x plus 3. Now I can factor out my y. I'm left with x minus 2 equals 2x plus 3. Divide both sides by x minus 2. And we get y equals 2x plus 3 over x minus 2. So f inverse is 2x plus 3 over x minus 2. And yes, again, we got the same function. Okay, let me get rid of this. Don't know. Can't say I don't know why it popped up. I do know why it popped up. Okay. It just does that on occasion. Did lose my pen. And I did it again. Okay, I guess it just didn't like being over in that corner when I was trying to circle the answer. But there you go. Now this can get us started on the homework. I'm going to have, we'll split this in 2 days. So you can start your homework 1 through 9 odd, 25 through 43 every other odd, and then 55 through 63 every other odd. Okay, good luck on that.